In this video, we're going to go over some examples of calculating probability. So let's say we have a bag of candy with 83 special dark candy bars and 17 Mr. Good Bar candy bars. So that's a total of 100 candy bars. And if we want to calculate, let's say, the probability of getting a special dark candy bar, we would simply take the subset A, which is 83 special dark candy bars, and divide it by the universal set, which is 100 events, which is basically the special dark plus the Mr. Good Bar candy bars, and we would get a probability of 0.83 of getting a special dark candy bar. Now, if we wanted to calculate the probability of getting a Mr. Good Bar candy bar, we would do that similarly, where we would take 17, which is the number of Mr. Good Bar candy bars in the bag, and divide it by 100, which is the total number of candy bars in the bag. Let's assume that we replaced the last one that we took out, and that would give us a probability of 0.17 or 17% of the time. If we reached in at random, we would pull out a Mr. Goodbar candy bar. Since that's the universal set, that's all that's in the bag, then adding the two probabilities together should get us to 1, or should be 100% of everything that's in the bag. Moving on to the additive rule of probability, or sometimes called the OR rule of probability, which states that given a set of mutually exclusive events, the probability of the occurrence of one event or another is equal to the sum of their separate probabilities. So basically, you would add the probabilities together if you want to know the likelihood of two or more events occurring for one outcome. So it's important to note that there's one outcome, but we're talking about the probability of the potential for multiple events potentially occurring for that outcome. So, for example, let's say we have a bag that has now 65 Special Dark, 30 Mr. Good Bar, and 5 Hershey bars, and we want to see what's the probability that we would calculate a Mr. that we would rather not calculate that we would retrieve a Mr. Good Bar or a Hershey's candy bar. So what we would want to do is first calculate the probability of the separate candy bars. So here we have Special Dark is 65% or 0.65 probability if we were choosing at random. Mr. Goodbar is 0.3 probability if we're choosing at random, and Hershey's is 0.05 probability if we're choosing at random. So to determine the probability of, on one trial, of choosing a good Mr. Goodbar or Hershey's, we simply add the two probabilities together, which gives us 0.35. Right? So 0.35 probability of choosing a Mr. Goodbar or Hershey's on one trial. Right? So that's how we would apply the additive or rule of probability. Now the multiplicative or end rule of probability is about joint probabilities. So this is more than one event co-occurring. So if you want to determine the probability of independent events co-occurring, you multiply those probabilities together. So what is the probability that when I reach into the bag, I'll first select a Mr. Goodbar, and let's just, to keep this simple, let's just say, and then I'll replace the Mr. Goodbar, shake up the bag, and then select a Hershey's. So I would take the probability of selecting a Mr. Goodbar, which we determined was 0.3, and multiply it by the probability of selecting a Hershey's bar, which was 0.05. Multiply those two probabilities together, and we get 0.015. So a little bit more than 1% of the time that would happen. We could also ask something like, what's the probability that if I select a Hershey's that I select a Hershey's bar, a special dark, and then a Mr. Goodbar. Assuming sampling with replacement here, we could multiply the three probabilities together, and we would see that that is likely to happen less than 1% of the time. We could ask, what's the probability that I select a Mr. Goodbar and a Hershey's candy bar on 2 tries? But this time we're ignoring the order. So previously we were specifying the order. Now let's say we don't care about the order. We just want to know what's the probability of getting a Mr. Goodbar and a Hershey's bar on 2 tries. So in order to do that, there's 2 ways that it could happen. It would be we'd select the Goodbar first and Hershey's second, or we would select the Hershey's first and the Goodbar second. And they both have the same probability, but there's 2 orders by which that could occur. So to determine that, we would actually use we would combine here the multiplicative rule of probability and the additive rule of probability to determine that the 0.015 plus 0.015 gives us a 0.03 probability, or that would happen about 3% of the time on 2 trials, and also assuming sampling with replacement. So to summarize, the additive rule occurs when there's one event or another event in a single trial, and we use addition to determine that probability. And the multiplicative rule is for joint probabilities. So this is the co-occurrence of 2 or more events, and so this implies multiple trials.